Hi, my name is Lingadarshan Anparasu, and I'm a cybersecurity master student. This is my cybersecurity master's project. My project will be explaining how to detect and mitigate biases in AI-driven loan approval systems. Now I'm going to be talking about the problem background of my project. The problem domain of bias detection and mitigation in AI driven loan approval systems encompasses critical areas including artificial intelligence, machine learning, ethics, and financial services regulation. Financial institutions increasingly use machine learning and artificial intelligence models to automate the loan approvals, aiming for efficiency and objective decision making. However, this automation introduces challenges related to fairness and transparency, as biases in the data or model design can lead to discriminatory practices. Historical lending data, for example, might reflect past inequalities which AI systems might perpetuate. Ethical concerns and regulatory requirements such as GDPR, the General Data Protection Regulation, and CCPA, California Consumer Privacy Act, mandate that protection of sensitive financial data, ensuring robust encryption and security measures. Strong authentication, authorization, and regular security audits are crucial to preventing data breaches and maintaining trust. The complexity of this domain is further deepened by the need for explainable AI to make decision making processes transparent and the ongoing adaptation of AI systems to maintain fairness over time. Addressing this multi-phase challenge requires a comprehensive approach that balances technical, ethical, and legal considerations, integrating robust security measures to ensure the effectiveness and reliability of the bias detection tools. Now I'll be talking about the research gap. Despite advancements in AI and ML within the financial sector, a critical gap remains in integrating security regulations with bias detection and fairness in automated loan approval systems. While current research delves into the technical capabilities of AI and ML for processing large datasets, it often lacks comprehensive methodologies that detect and mitigate biases without compromising predictive accuracy. A major shortcoming is the focus on post hoc bias identification rather than addressing how biases are embedded during the training process. This highlights the need for interdisciplinary approaches that consider the legal, ethical, and social dimension, ensuring compliance with regulations like the GDPR and the ECOA and the FHA, which is the Federal Housing Administration, which administers a program for loan insurance to expand homeownership opportunities. Additionally, existing studies frequently overlook the diverse nature of biases and the complexity of financial decision making, lacking versatile tools that adapt to various biases and complex environments. There's also an insufficient focus on integrating validation mechanisms to ensure the effectiveness of these tools in real world scenarios. Addressing this gap is essential for promoting fair lending practices that align with dynamic financial markets and evolving legal and societal expectations regarding discrimination and fairness. This research aims to provide comprehensive tools and frameworks for bias detection and mitigation, ensuring regulatory compliance and validating their effectiveness to enhance the fairness and transparency of automated financial decision making systems. Now I'll be talking the aim of this project. The principal challenge of this research lies in identifying and quantifying bias within AI driven loan approval systems, which is complicated by the opaque nature of many machine learning models. These black box models do not easily reveal how input data translate into decisions, making it difficult to identify where biases may influence outcomes. Another significant hurdle is developing mitigation strategies that effectively reduce bias without impairing the predictive accuracy or operational efficiency of these systems. Balancing fairness with financial risk assessment requires innovative approaches that consider the multi-phase nature of bias and its origins in historical data. Additionally, aligning technical solutions with legal and ethical standards is crucial, ensuring compliance with regulatory requirements and societal values. Addressing these challenges necessitates a nuanced understanding of both the technical aspects of AI and the broader societal context of financial decisions, emphasizing the need for interdisciplinary research and collaboration. This research aims to design, develop, and evaluate innovative methodologies for detecting and mitigating bias in AI driven loan approval systems, ensuring their alignment with the ethical and legal standards without compromising predictive accuracy. Now I'll be talking about my contribution to the body of knowledge. The development of the bias detection tools contributes significantly to the existing body of knowledge in several key areas. First, the integration of bias detection and regulatory compliance, the unique integration. One of the primary contributions is the unique integration of bias detection methodologies with regulatory compliance requirements. While existing tools and research primarily focuses on either bias detection or compliance, this tool bridges the gap by embedding compliance checks within the bias detection process. This ensures that tool not only identifies biases but also aligns with regulations such as General Data Protection Regulation (GDPR) and Fair Housing Act (FHA) and Equal Credit Opportunity Act (ECOA). Second, comprehensive methodology for bias detection, holistic approach. The tool adopts a comprehensive methodology that addresses the multi-phase nature of bias in AI-driven loan approval systems. It includes pre-processing, in-processing, and post-processing techniques to identify and mitigate bias, ensuring a thorough examination and correction at various stages of AI model lifecycle. Number three, enhance explainability and transparency by utilizing SHAP, Shapely Additive Explanation. By incorporating SHAP, the tool enhances the explainability and transparency of AI models. SHAP provides insights into how each feature contributes into the model predictions, which is crucial for understanding and mitigating bias. This contribution is particularly important as it helps demystify the black box nature of many ML models. Number four, real world application and validation, empirical validation. The tool's effectiveness is validated using HMDA Home Mortgage Disclosure Act dataset for 2022, which includes comprehensive loan application information. This real world application ensures the tool's methodologies are robust and applicable in practical scenarios, providing actionable insights for financial institutions. Number five, interdisciplinary approach, bridging multiple disciplines. The research takes on an interdisciplinary approach by integrating insights from computer science, law, ethics, and finance. This holistic perspective ensures that the tool not only addresses technical challenges but also considers the legal, ethical, and societal dimensions of bias in automated lending. Number six, contribution to fair lending practices, promoting fairness and inclusion. By providing a robust framework for detecting and mitigating bias, the tool contributes to promoting fairness and inclusion in financial lending practices. It helps ensure that AI driven loan approval systems serve all segments of society equally, addressing historical biases and fostering greater trust in automated financial decision making. And finally, the educational value, resource for learning and development. The tool also serves as a valuable educational resource for those studying AI ethics, bias detection, and regulatory compliance. It provides a practical example of how to integrate these elements into the cohesive system, helping to train the next generation of AI practitioners and policymakers. In summary, this bias detection tool advances the field by offering a comprehensive, compliant, and transparent solution for identifying and mitigating bias in AI driven loan approval systems. Its interdisciplinary approach and practical application ensures that it addresses both technical and societal challenges, contributing significantly to the pursuit of fairness in automated financial decision making. Now I'll be talking about the future enhancements. Building on the findings and addressing the limitation encountered during the development of the bias detection tool, several potential improvements and avenues for future work can be proposed. These enhancements aim to further refine the tool's capabilities, broaden its applicability, and address identified limitations. Enhance algorithmic techniques, incorporation of advanced bias detection algorithms. Future work could explore integrating more advanced algorithms for bias detection, such as those leveraging deep learning or ensemble methods. These techniques may improve the accuracy of bias detection and provide more nuisance insights to complex biases that traditional methods might miss. Adaptive bias detecting mitigation strategies. Developing adaptive bias mitigation strategies that can dynamically adjust based on real-time data and evolving lending practices would enhance the tool's effectiveness. Implementing ML models that can learn from new data and adjust mitigation techniques accordingly could improve the tool's responsiveness to emerging biases. Improve data handling. Expansion of data sources to address a limitation related to the data availability and representativeness. Future enhancements could include expanding the range of data sources, incorporating diverse data sets from various financial institutions and geographical regions would improve the tool's generalizability and performance across different contexts. Synthetic data generation. Utilizing synthetic data generation techniques to create diverse and representative data sets for training and testing could help overcome the limitations of real world data constraints. Techniques such as data augmentation and simulation could provide additional data to enhance a tool's robustness. Advanced user interface and experience. Enhance user customization. Future versions of the tool could incorporate advanced user customization features, allowing users to tailor the tool's functionalities and interface to their specific needs. Providing customizable dashboards, reporting features, and integration options could improve user experience and applicability. Multi-language and accessibility features. Expanding the tool's interface to support multiple languages and incorporating accessibility features would make it more inclusive and user-friendly for a global audience. Broader regulatory compliance, integration of regulatory frameworks. To enhance the tool's adaptability to diverse regulatory environments, future enhancements could involve integrating specific regulatory frameworks and compliance requirements. This would ensure that the tools remains effective and compliant across different jurisdictions. Implementing mechanisms for automatic updates and adaptation to changing regulations would keep the tool current and relevant in the face of evolving legal requirements. Ongoing evaluation and feedback, continuous feedback mechanism. Establishing continuous feedback mechanisms for end users, domain experts, and regulatory bodies would provide ongoing insights into tools' performance and areas for improvement. Regular updates based on user feedback and evolving best practices could drive continuous enhancement. Conducting longitudinal studies to address the long-term impact of the tool on lending practices and bias mitigation could provide valuable insights into the effectiveness and guide future developments. Ethical and bias consideration. Future work should continue to address potential biases in the tool's development process, implementing rigorous external audits and including diverse perspectives in the development team could mitigate biases and enhance tools' fairness. Transparency and accountability. Enhancing transparency and accountability mechanisms within the tool, such as providing detailed explanation of bias detection results and mitigation recommendations, would further support ethical AI practices. These proposed enhancements aim to build on the successes of the current research while addressing its limitation. By incorporating advanced techniques, expanding data handling capabilities, improvising user experience, and ensuring regulatory compliance, the tool can be refined and extended to better meet the needs for financial institutions and contribute to more equitable lending practices. The continuous pursuit of innovation and improvement will be essential in advancing the field of bias detection and ensuring the tool's ongoing relevance and effectiveness. Hello, I'll be explaining the core code right now. So the core code is in the rf underscore model underscore downsample.py. So in this line, in line number 150, I'm loading the data set from the CSV file located here into a pandas data frame named as df, and in here I am printing the counts of each unique value in the action column, which presumably indicates the loan approval, one or denial. Uh, yeah. In line number 156, this is moving the loan application status into the last column. So this line records the columns of the DF so that action column is the last column. It creates a new list of columns by including all columns except action first and then adding action at the end. Okay. Now the next one is separating the minority and uh, majority classes. These separate this basically separates the data frame into two data frames: DF majority, where the action is one, that means loan approved, and DF minority, where the action is zero. So that is basically loan denied. Afterwards, I'm downsampling the majority class. So in line number 163, this line downsamples the majority class DF majority to have a same number of samples as the minority class. It does this. I'm doing this by randomly sampling rows from DF majority, ensuring reproducibility with random state equal 42. After that, it's combining minority class with the downsample majority class. This line basically concatenates the minority class data frame, the DF underscore minority, and downsample majority data frame to create a balanced data set. This will make sure the data will not be imbalanced. And after that, it's basically displaying the new class counts. So this line prints the counts of each class in the balanced data frame to confirm that the classes are now balanced. Next, it's defining the new features and target. This line defines basically it defines this X balance as the data frame containing all the columns except the action, the feature O, and the Y balanced has the action column that with the target variable. Let's continue. After that, it's basically we are saving this data set, saving the balanced data set. So this line saves the balanced data set to a new CSV file located here without the index column it is saving. After that, after that is displaying data types of features. This line prints the data types of features in the X balance to ensure that they're correctly formatted for model training. Let's continue. Yeah, here, here. Now, this line is splitting the data set into training and testing sets. This line splits the balanced data set into training and testing sets. X train and Y train are the features and the target for the training set, respectively. X set and X test and Y test are the features and target for the testing set. The test size is 20% of the data set. Random state 42 ensures the reproducibility. Next one is the we are initializing the AI model, so the ML model, the initializing the random forest classifier. Line number 184. This line initializes a random forest classifier with 100 trees, and this with 100 trees, balanced class weights, balanced class weights, and parallel processing using all available cores. This this random state 40 equals 42 ensures the reproducibility. After that comes training the model. This line trains the random forest classifier using the training data x underscore train and y underscore train. So after that, it's making the predictions for the test set. Here, line number 190. This line makes predictions on the test set x test and stores the predicted results in y underscore pred. After that, it's evaluating the model. These lines from line number 192 to 194, these lines call the evaluation functions defined earlier, which I'll explain later, to assess the model's performance. Evaluation save underscore plot equal true. This line here, line number 192, evaluates the model and saves the evaluation plots. The next line, threshold underscore move, adjusts the prediction threshold and saves the model's performance with a new threshold. External underscore validation. This line performs a cross validation, I'll explain shortly, to assess the model's performance. After that, it's one of the last steps. We are basically saving the model. This line saves the trained random forest model to a file name rf underscore classifier underscore downsample.pk. That is saved here. Here. So it saves the trained random to this file using joblib. Next one is generating the SHAP plots. This line generates the SHAP plots for a trained model to interpret the feature importance and save the plots. Next, I'll be talking about evaluation. Okay. Now I'll be talking about the evaluation part. So in this function, I basically evaluate the model. So let's begin. So it starts from line number 17 onwards. So it's used to, so this function is named evaluation and it's used to evaluate the performance of the trained random forest classifier, trained random forest classifier. So it generates evaluation metrics, plots, and optionally saves these plots. So it takes three parameters: the save plot, Boolean. If the default is false, if it is true, the plots will be saved to disk. Show plot Boolean. If it is true, the plots will be displayed. And plot directory, it's basically a string, the directory where the plots will be saved. Okay. Now let's continue. So for line number 18, we are this line prints the classification report, which includes the precision recall, the F1 score, and the support for each class. It provides a quick overview of how well the model is performing on the test set, X test and Y test. Next one. Next one. In this code block, line number 20 to line number 25, the highlighted code block. So this is basically calculating and printing the feature importance, the important features basically. So this line number 20, it retrieves the feature importance from the train model. After that, it gets the feature name from the training set and creates a directory mapping each feature to its importance. After that, it's sorting the features by the importance in descending order. And then finally, it's looping each feature and its importance. This helps in understanding which features are most influential in the model predictions. Next, these two. Basically converting feature importance to series for plotting. It converts the feature importance and their corresponding feature names into a panda series for easier manipulation and plotting. Then after that, it's sorting the series in the ascending order of importance for better visualization in the plot. Next, line number 33 to line number 35. This is computing the ROC curve and the AUC. So the true positive, this false positive and the true positive rate are calculating the ROC curve function. This function computes the ROC curve by comparing the true labels y test with the predicted probabilities RF classifier, basically this one, with the predicted possibilities. And then after that, it calculating the area under the ROC curve, the AUC, which is a single scalar value summarizing the model's performance across all classification thresholds. Next. Next is from line number 37 to line number 54, right here. So this code block is for plotting the ROC curve. It generates and optically saves and displays the ROC curves. It checks if the plot directory exists, create it if necessary. It plots the ROC curve, and the PLT commands, it commands for the formatting the plot, and it will save the plot as a image, and it will display in the screen as well. This is basically to free up the memory. It closes the plot to free up the memory. Next. The final one is the feature important plot, the plotting the feature importance. From line number 56 to line number 64. So this block generates and optionally saves or displays a horizontal bar plot for the feature importance. So similar to the ROC plot, the feature plot is saved plot is true, and displayed if show plot is true. In summary, this entire evaluation function is a comprehensive utility for evaluating the performance of the random forest model. It prints the classification. It has 4 features. It prints the classification report, prints the importance of each feature, plots and optionally saves the ROC curve, and plots and optionally saves the feature importance. These steps will help in understanding the model's performance, diagnosing potential issues, and interpreting which features are most likely important for the model predictions. Okay. Now that I explained the core code and evaluation, I'll be running it. I'll give you a demo. Okay. So as you can see, it opens a Streamlit app. So in here, these are all the features that you can add. All of these are randomly generated. All the features you can add, you can change this. Loan type, property value, everything can be changed. And then loan approval status, you can give whether the loan is approved or not by the AI. So if you say denied and submit, okay. Now it's giving a not biased result. This decision is basically not biased. This is basically showing all the important features, and the current threshold is 0.37. So that is less than the threshold. And this is showing how long the Features are the sharp value. Now, for example, if I put it as approved, biased. Now, this is now a biased decision. So, like that, or the user can input the AI data and all the loan application data and see whether the AI has approved the loan request or not, and it will show it. So, if I can change this, for example, and submit like this, not biased. It changes it. So it's 0.67 is greater than threshold, so not biased. So threshold can be adjusted. Right now it's 0.5. Yeah. Finally, for the conclusion, the development and evaluation of the bias detection tool for fair loan approval systems represent a significant achievement in addressing and mitigating biases within financial lending practices. This project not only illustrates the transformative potential of technology in fostering fairness and transparency, but also establishes a benchmark for future innovations aimed at promoting equity and justice. The project showcases the effective use of ML and AI in complying with stringent regulatory compliance such as the General Data Protection Regulation (GDPR), Health and the Health Insurance Portability Accountability Act (HIPP) HIPAA. By ensuring adherence to these data protection and privacy standards, the tool demonstrates a commitment to upholding critical ethical and legal benchmarks. The integration of robust bias detection mechanism highlights the importance of ethical considerations in technology development. The insights and methodologies derived from this work contribute to the evolving dialogue on ethical AI and social justice, reinforcing the need to align technological solutions with security and compliance measures. The project's success underscores the value of interdisciplinary collaboration in addressing complex issues. Combining expertise from data science, ethics, and finance leads to meaningful advancements and solutions. This journey emphasizes the necessity of ongoing refinement and adaptation in technology development. By navigating technical and regulatory challenges, the project highlights the importance of continuous improvement and responsiveness to evolving needs and standards. This project sets a precedent for future developments in the field of ethical AI, providing a foundational model for addressing bias and promoting fairness in various domains. It encourages future further research and innovation focusing on maintaining alignment with the evolving legal frameworks and ethical standards. As financial sector and technology continue to evolve, maintaining a dual focus on innovation and compliance will be essential. The commitment to addressing biases, safeguarding data, and adhering to regulations will guide future enhancements, ensuring that the technological process serves the principles of fairness, transparency, and security. In conclusion, the bias detection tool represents a significant step forward in leveraging technology to improve the operational efficiencies and enhance social equity within lending practices. It underscores the potential for technological advancements to create a more and just, equitable financial system. Moving forward, the dedication to ethical AI and regulatory compliance will remain central to ongoing research and development, driving continued progress to this vital area. This project not only marks a crucial milestone in addressing systematic biases, but also lays the groundwork for future innovations that prioritize fairness, transparency, and inclusivity. Thank you.